Unit 16 review. On the first few problems, they just want you to express the following equation in exponential form. So if it says exponential form, you have to have an exponent when you do it. So again, that's saying the base is the base and the other switch place. So here's your base, and then these two switch place. So 3 to the power of a equals b. Same thing here, here's your base, the other switch place. So 20 to the power of 14 equals x. Alright, and again, 32 to the power of 1/5 equals 2, and x squared equals 25. Alright, on the next one, it says express the following equations in log form. Well, if it says log form, you have to have log when you write the expression. So here's your base. So log base 2 of 300 equals x. The base is the base and the other switch place. Okay, same thing here. You're going to have log base 5 of 20 equals x plus 8. And again here, there's your base. So log base a of c equals b. Same thing here. Now this one is a little bit different. You will have a log, but remember it's a natural log of 20 equals x. Alright, on the next one, really the best way to do is to substitute this. You could also put this into y1 and y2 in your calculator to see which one is the correct answer when you're looking at the table. But if you just substitute these values in, whichever one will give you a negative number is the one you want. So for instance, here I have negative 9 times 3 is negative 27, minus 2 is negative 29. Well, that gives me a negative number in there, and you cannot have a negative number. So that cannot be the answer. And if I substitute this in, negative 7 squared is 49. 49 plus 12 is 61. That's positive. That works. And here, again, if I plug in negative 7 over here, negative 9 times negative 7 is 63. Minus 2 is 61. So that's your answer. Alright, on this one here, when you see adding, you're actually multiplying. So you want to set up an equation. So log of 8x equals 2. Remember, your base here is 10. So now you're going to have 10 to the power of 2 equals 8x. Divide by 8, divide by 8. 10 squared is 100. 100 divided by 8 is 12.5. Okay, on this one here it says find the value of x in the following equations. So the main thing here is you always want to get the base and the exponent by themselves. That's the most important thing. You're always getting that base and that exponent by themselves. Almost circled the 4 there. Alright, so I'm going to add 3 here. Add 3 here. So that gives you 5 to the power of 3x equals 15. And again, I do the base is the base and the other switch place. Now, still solving for x, so I need to divide by 3. So when I put that in my calculator, I'm going to find out that log base 5 of 15 divided by 3 is approximately 0.56. Okay, same thing here. I already have my base and my exponent by myself. So the base is the base and the other switch place. And again, if I use my calculator, I have log base 9 of 4 equals approximately 0.63. Alright, on this one here, again, I'm trying to get that base and that exponent by itself, so I'm going to subtract 2. That gives me e to the power of x minus 4 equals 8. And again, I've got my base and my exponent by myself. So I'm going to do the base is the base and the other switch place. And then I'm just going to add 4 to that. Now, the most important thing about this is when you put it in your calculator, do not put the 4 in the parentheses. So if I do len of 8, I want to close off that parenthesis, and then I want to add 4. And then you get about 6.08 if I'm rounding to the hundredths. Okay, on the next ones, I'll probably only do one more, or maybe 2 more. These 2 are going to be very, very similar. So I'll do this one. The only difference here is you want to add. So here I'm going to minus 3. That gives me 8 to the power of n plus 10 equals 64. And again, the base is the base and the other switch place. And again, once again, when I type this in my calculator, notice how the parentheses pop up when you do the log. So here, I'm going to do log base 8 of 64. Again, I'm going to go outside those parentheses, and then I'm going to subtract the 10. Do not put the 10 in the parentheses. You would not get the right answer. So x is approximately 8.5. Or actually, exactly. So it's exactly 8.5. Okay, on this one here, you'll notice that I don't have my base and my exponent by themselves quite yet. So I'm going to divide by 4. Divide by 4. That gives me e to the power of x equals 10. And again, the base stays the base, and the other switch place. And if I do the natural log of 10, I get about 2.30. So x is approximately 2.30. Okay. On the back side, again, we're just continuing, but this time now we're going to go from log to exponent. So on this one here, you'll notice I have this half. Well, I need to get rid of that half. So I'm going to multiply by 2, because that gives me 1. But whatever I do on one side, I have to do the other, so times 2. So now I have log base 2 of x minus 5 equals 6. And again, there's my base. So I'm going to, if I have a log, I've got to use an exponent to solve it. So the base is the base, and the other switch place. So 2 to the power of 6 equals x minus 5. And then plus 5 and plus 5. Alright, so if I do 2 to the power of 6 plus 5, I get 69. So x equals 69. Alright, on the next one. I'm going to, I notice I have a number in front of the log, so I need to get rid of it, because I want to get that log base and that number by itself. So I'm going to rewrite this a little bit different. Okay, so here again I'm doing the exact same thing. I got the log, the base, and the x all by itself. So I'm going to do the base is the base, and the other switch place, and x equals 8. Alright, same thing here. I got something in front of the log. I got to get rid of it. That gives me log base 5 of x equals 3. And once again, the base is the base, and the other switch place. So x equals 125. Okay, so to continue, again, I don't have anything in front of the log here, nor do I have anything outside the parentheses. So I can go straight to the base is the base, and the other switch place. That gives me 16 equals x plus 2, minus 2, minus 2, x equals 14. Alright, now on this one I do have this 2 right here, so I need to get rid of it. So I'm going to divide by 2 and divide by 2. That gives me the natural log of x plus 2 equals 2.5. And again, I can do the base is the base, and then the other switch place. And so that would actually leave me with x equals e to the power of 2.5 minus 2. Now that E button, if you don't remember, is a couple different ways to get to it. You can use the second division sign, or you can use the second natural log, which again, that is the inverse. I'm going to use the second natural log, and I'm going to put 2.5, and then I'm going to subtract 2. And I just noticed I left my decimal off there. There we go, that should work. And then you get about 10.18. So I'll write the answer here. So x is approximately 10.18. Okay. On the last one here, again, I'm going straight to the base is the base because there's nothing here and there's nothing being added after the 7. So x to the power of 3 equals 7. Now this kind of goes back a few units. You have to kind of remember where this button was. So I got to do a cube root to get rid of that 3. So I'm going to do the cube root. And if I go to math 5, or actually math 4, since it's a cube, I can just use that one. And then put 7, and then enter. So about 1.91. So x is approximately 1.91. Alright, on the next part of this, I really just want you to determine the base. So again, on the log, the base is kind of the subscript. Now you'll notice there isn't one here, but it is a 10, understood to be there. Your base here is 2. Your base here is 7, and this is your e. Alright, on the next one, you're just evaluating, so you're really just looking to put it in the calculator. So I'm going to do log of 100. That's a perfect little number. It would be 2. On this one here, I'm going to do log of log base 3 of 20, and that's going to give me 2.73. And then this one, I'm just doing ln 7, so natural log of 7, and it's 1.95. Okay. All right, on the next ones here, I'm just really kind of writing equations, and I'm going to solve for time. So it says a scientist starts with a sample of 50 bacteria that increases by 60% each hour. Now, if the rate is a percent, I know I'm going to be using the growth and decay formula for exponential growth and decay. Write and solve an equation to determine approximately how long it would take before there were 900 bacteria. Well, it seemed to grow, so I'm going to use the positive one. Now, this y here, this is my future amount. That's my future amount. So I'm going to have 900 equals the starting amount, which is 50. It's growing, so 1 plus, and then you have to change that into a decimal. So 0.60 to the power of x. Alright, so I want to try to get my base and my exponent by itself like I've always done. So I'm going to divide by 50. Divide by 50. Alright, and then 900 divided by 50 gives me 18. So I'm going to have 18 equals 1.6 to the power of x. Now at this point is when I can do the base is the base. So the base is the base and the other switch place. So for your equation, y'all, I would accept this is the equation because that is an equation. But you could also do it as 900 equals 50 and then 1.6 to the power of x. Now as far as my answer, let me plug it in. So I have log base 1.6, 18, and that gives me approximately 6.15. I'm rounding to the hundredths there. Okay, art tends to become more valuable after an artist dies. From the time a particular artist dies, her art started appreciating, which is growth, by 8% every year. If a painting went for $10,000 at the time of her death, how long would it take to triple in value? Well, triple means I'm going to take that 10,000, that's going to be my future amount. So in the future, I want to see how long it would take for it to triple. It starts off at 10,000. It's growing at a rate of 8%, so 0.08 is a decimal. So I'm going to divide by 10,000 here to get that base and that exponent by itself. So that gives me 3 equals 1.08 to the power of x. And again, the base is the base and the other switch place. So if I do log base 1.08 of 3, I get about 14.27 years. So 14.27 years. Alright, and then again for your equation, you could do the 30,000 equals 10,000, 1.08 to the power of x. Alright, I hope that helped you. Good luck on the double quiz.